Okay, so I will start this live stream in a minute. Sorry for the delay. All right, cool. So today we're going to continue work on what we learned from last week, which is the statistic and probability related problem. So let's first take a look of the first problem. I'll grab my pen. So it says Shauna takes 5 tests. Each works a maximum of 100 points. So the information here is that, all right, let me double check the connection. Okay, so it said that Shanna takes 5 tests, each worth a maximum of 100 points. And let's highlight the keywords. So first is 5 tests, then the maximum for each test is 100 points. Her scores on the first 3 tests are 76, 94, and 87, right? So in order to average 81 on all 5 tests, what is the lowest possible score she can get for one of the other 2 remaining tests? So for this problem, how about let's first start with finding what's the total score for the 5 tests. So I will say the goal is get an average of 81 for 5 tests. So that's 81 times 5, which equals to 405, right? So that's the goal for the test. And she's already finished 3 among the 5 tests. So I will say sum of the first 3 tests. Sum of the first 3 tests. This can be calculated as just adding up these numbers, which is 76 plus 94 and plus 87. So their summation should be 257 in total. And okay, I zoom in too much. Okay. So what is the lowest score she can get? So how about now let's using the total of the 5 tests minus the already taken 3 exams so we can know what is the sum to be needed of the last 2 exams, right? So let me change my pen's color. I will do this one in green, okay? So I will say, wait, this is not my pen. Okay, this is my pen. So let me change it to green. Good. So now I will write for the last 2 tests, sum of the score needed for the last 2 tests, sum of the score of the last 2 tests. Okay, so this should be 405 subtract 257, so that the answer is 148, right? So for the last 2 tests, Shanna, in order to achieve her goal, she must get 148 points in total. And since we know the maximum points for one test, so maximum score for a test is how many points? Is 100 points, right? So in this case, we are facing a situation where the summation is a fixed number, a constant. So this means one of the addition number is increasing, have to be influenced into the other number to be decreasing, right? So since we are looking for the lowest score on one of the tests, so this actually means that we're going to look for the highest score on the other. So these are equivalent relationship, right? So maximum for a test is 100. So the lowest score for the other test can then be defined as 148, the total score for the 2 exam, minus the maximum for one test, so you get the minimum for the last test, right? Which is 48. Okay. Sorry. So among the A, B, C, D, E, so 5 options, we choose A, 48, right? So that's for this problem. Okay, let me redo this part. Good. Okay, now we're on to the second problem of today's live stream. It's going to be roughly the same, but since it's an exit ticket, it's going to be more challenging, okay? So what is the sum of all real numbers x for which the median of the number 4, 6, 8, 17x is equal to the mean of the 5 numbers? So how about let's first start with calculating the mean of this sequence. So I will say the mean is equal to 4 plus 6 plus 8 plus 17 and plus x. So these are 5 numbers, right? So finding the mean means find the summation and divided by the numbers we have, which is 5. So in this case, it's actually equals to, so that's a 10, that's a 25, okay? So 35 plus x divided by 5. If you make a further simplification, you can get is 7 plus x over 5. So that's for the mean part. Now, what are the other conditions? So we're looking for that the median of this sequence is going to be the same as the mean. So there are several possible cases for the median. Let's try the method of enumeration, which means we're going to list them case by case. So I will say there are 3 possible cases. Okay, so there are 3 possible cases. The first one is really dependent on the position of x among this list, right? So the first one can be 4, 6, 8, 17, and x, right? So this one, it doesn't really matter if you write it as 4, 6, 8, x, 17, because for the median, when the list is consisted of all numbers, the median is just a middle number, right? In this case, we have 5 numbers, which is odd, and the median is going to be the third number with 2 in the front, 2 after. So it doesn't matter if we put 17x or x17. So in this case, I would say the median is 8, right? In the middle, after alternating from the least to the greatest. So I'll highlight the median, which is 8. Now for the second possible case, I will put, oh, sorry, let me write it better. So, okay, for the second possible case, I will say we have x 4, 6, 8, 17. Again, this is actually the same as you put 4x 6, 8, 7, right? As long as there are 2 numbers in front of 6 and 2 numbers greater than 6, we are following the second case. So in this case, the middle number in this list is a 6. So, okay, let me highlight the median. So in this case, we get a 6. Good. All right, let me zoom out a little bit so I have more space to write. Okay, cool. Now we have one last possible case, right? What is that? That's our third case, which is we have, okay, 4, 6, x, 8, and 17. In this case, x is in between 6 and 8, so it gives x to be the median, right? So x. Okay, after understanding all the possible cases we have, we can investigate each case, right? So let's first try the case number 1. So I'll put it here. Case 1, that is when the median is equal to 8, right? So when median is 8, so it has to be equal to the mean, right? So we're given that the median of the number is equal to the mean. So the mean is 7 plus x over 5. So I will write 7 plus x over 5 on the left-hand side of equality, then 8 on the right-hand side. So this will actually gives you that. Okay, let me write it better on this. So this will actually give you x over 5 equals 1, right? So this is equivalent to say that x equals 5. So think about that. If x is equals 5, when finding the median, we're altering these numbers from the least to the greatest. And x is supposed to be more than 8 or more than 17, right? But the minimum requirement is x is more than 8. But 5 is less than 8. So I will say 5 is less than 8. Or 17, right? It really depends on what's the order you put. So this cannot be true. So, okay, let me put a red cross on it. We know this case is not valid. All right, cool. So how about let's try our case number 2. For case number 2, so we have the median to be 6, right? Median equal to 6. This means we can set up the equation as 7 plus x over 5 equals to 6. This tells you x over 5 equals -1, which is the same to say that x equals to -5. All right, let's try to plug in value to test if this case is applicable, okay? So if x is -5, of course it's less than 4, less than 6, less than 8, less than 17. So this means we have the least to be -5, come with a 4, with a 6, with an 8, with a 17, right? So in this case, there's nothing wrong. So we know this is actually the case we need to put into consideration. I will put a yellow check mark at the end. So we know case number 2 is valid. Good. So how about our last case? Okay, looks like a run out of space. So I'll put it here. So for case number 3, so the median here is just x, right? Median equals to x, so the equation now becomes 7 plus x over 5 equals x, so that if you multiply by 5 on both left and right hand side of the equation, you will get 35 plus x, right? So times 5 is equals to 5x. So this one actually equivalent to say that 4x equals to 35. So x is equal to 35 over 4. So think about now our restriction that x must be 4 between 6 and 8. But 35 over 4 is more than 8, right? Because 4 times 8 is 32. So this one's definitely out of the bound. So since x is more than 8, this case cannot be true, right? It must be 4 within 6 and 8, so they will become the median. If it's more than 8, then x is no longer median, which violates our assumption. So this one's true. This one's false for sure. And now we see the only possible case is this one, which is x equals to -5, right? This is the only one we put a check mark on it. So this is the only possible case. And I think the question asking for what is the summation of all the real numbers? There's just one case, so a summation is just a number itself, right? So we choose A, -5 on this exit ticket. All right, this is a challenging problem, but we definitely solve it. Okay, so here is a quick information session. And it's basically telling you we are going to have the AR and HR class upcoming, and there's going to be our second round AMC mock test. If you're interested, you can add me on the WeChat, which is ThinkVip60. Also, there's a Facebook group you can join. Okay, it's called AMC Helpful and Educational Math Resources. So when you become a member of this group, you are now going to see a lot of good problems you can use to prepare for the exam. But also there will be some valuable exchange of information of how to get ready for the AMCA. Okay, so that's for this part. Now let's get back to the problem solving session. I think that's our third problem, right? So okay, let me see. Good. So for the third problem, we're having a condition that 10 tires number from 1 to 10. Alrighty, so let me change my pen's color to blue. So there are 10 tires, number 1 to 10. They are turned face down, right? So one tire is turned up at random, and a die is rolled. So we are assuming this is a fair die with 1 to 6 numbered on each of the sides. So what's the probability that the product of the numbers on the tire and the die will be a square? So think about what is the extreme case. So maximum possibility, I would say. Maximum possible. So this will be 10 on the tire, right? The largest number you can have on a tire in this case is a 10. And the largest number you can have on a die is a 6, right? So 10 on the tire, 6 on the, oh, sorry, let me write it better. So it's called 10 on the tire, 6 on the die. In this case, we are looking for their product, right? So the maximum product is 10 multiplied by 6. So 10 times 6, which equals to 60. So that's the largest possible number you can have. Since we're asking for how many squares do we have, so we are basically looking from the first square, which is 1, to 60, everything in between that counts as a square. So how about let's list them? It's not too much. So again, we can apply the method of enumeration, right? So here are all possible squares. All possible squares, that is less than 60. So 60 now is our upper bound. Less than 60. Okay, good. So the first one definitely is 1, right? Which means 1 is on the tire, 1 is on the die. So 1 times 1 is a 1. And you can have 4 is a square, 9 is a square. The next one is 16. The next one is 25. And we should have 2 more, which is 36. And last one is 7 square, which is 49. So let's write. Okay, I zoom in too much. Let me zoom out a little bit. Okay, cool. So now how about let's write down what are the other pairs that give you these squares. So I will say comma, all possible pairs are, so the first one should be 1 comma 1 because 1 times 1 gives you 1 as a square, right? So let's say for the pairs, we're putting the notation as number of pair come first. Well, number of die comes second. Okay, so this is not only a pair, this is actually an order pair because it's like the coordinate pair you use. X and Y, their order doesn't matter. Since the tire are numbered from 1 to 10, while the dice only have 1 to 6 on the side. So they have difference in their numbering. So that's why we need to consider the order, right? So let's put tire first, then die, using this order consistently. So first one is 1, 1. Then it can definitely have 1, 4 to come with a square of 4. I can have 2, 2. Then we can have 4, 1, right? 1, 4, and 4, 1, they are two cases. 1, 4 means 1 show up on the tire, 4 show up on the die. Well, 4, 1 denotes that 4 now is on the tire, while 1 is the number shown on the sides of a die. So these are two completely different cases. Let's try not to be confused on this, okay? So 4, 1 will be our 1, 2, 3, 4 fourth cases. Then for the square of 9, we have got 3, 3. So also a 9, 1. Can we get 1, 9? No. There's no 9 sides on the die. There are only 6 sides, right? So you again see why this order pair. So we have 4, 4 for the 16, and definitely 8, 2, right? So there should be a few more. 5, 5 for the 25. That's the only case for getting a square of 25. And 6, 6. Notice 6, 6. We can also have it as 9, 4, right? So I will say 9, 4. 9 on the tire, 4 on the die shows up. So 9, 4. Can we have 49? Although 49 is less than 60, less than the upper bound, but this requires a 7, 7. The maximum number you can have on a die is 6 because it only has 6 faces. You cannot have a 7 on a die. That's not even possible, right? So that's not a case we need to consider. So let's just count it, okay? So what are the numbering? Let me use a different color for better visual purpose. So that's 1, that's a 2. That's our third one, fourth pair, fifth pair, 6, 7, 8, 9, okay? 10, and 11. So there are 11 possible pairs that satisfy our requirements. So 11 pairs that have their product to be a square, right? Have their products to be a square. Okay, good. So what are the total possible cases we can have? That's easy, right? That's 60. You already have it here. Although it's called maximum product, but also think about it. For each of those 6 numbers shows on the tire, each of them can correspond to 1 to 6 on the die. So that should be 6 times 10, right? So I would say in total, there are 6 times 10 equals to 60 possible pairs, right? In this case, it's asking for the probability, the fraction. So the answer is, so I'll say the probability is just 11 over 60, right? The number that we are interested in over the total possible outcome. So 11 over 60, this gives us option C is correct. You see how we tackle problem like this, right? So first consider about if there's a lower bound, if there's an upper bound. Then if the number is not too large, for example, it's a double-digit number, we can list every possible cases using the approach of enumeration. Then after that, there may be some other restriction. For example, the maximum number on tire is 10, the maximum number on die is 6. So after all these, we can just apply them all together and find the final conclusion, right? Okay, so that's for our fourth problem, sorry, the third problem of today's live stream session, which means there are 4 more, okay? So in AMC 8, this is a real exam problem from the 2013 AMC 8. So let's see how can we tackle this, okay? So a fair coin. So a fair coin is tossed 3 times and is asking for what is the probability of at least 2 consecutive heads. Okay, so there are a few keywords. Let's highlight them. So, okay, let me change my pen's color. Good. So a fair coin, what does a fair coin mean? It means the probability of getting a head and a tail is the same. They are distributed evenly, right? 50-50. So now let's still try to use the enumeration method because it's only tossed 3 times, not 300 times. What is the probability of at least 2 consecutive heads, right? Okay, good. So now for this case, let's consider about our first possible case, which is at least 2, means we're starting from 2. So I would say 2 heads is our first consideration. Okay, cool. So first one can be HHT. Again, H denotes for a head, T denotes for a tail. Then the second one can be THH, right? Double H for the 2 consecutive head. So do you think HTH counts as one of those cases? No. It must be consecutive. What does consecutive mean to you guys? Consecutive means there should be no gap in between. So it should be H followed directly by a H, not H with a T in between, then another H. That's not called consecutive, right? It's not, it's a gap. So this one cannot be put into consideration. Let me put across. Okay, let me zoom out a little bit. Okay, cool. So now that's for the case number 1. So we have another case, right? Since it's towards 3 times, and we can definitely consider about we got 3 heads. So case number 2 is instead of 2 heads, we get 3 heads. So let me rewrite that. Oh, good. So for 3 heads, this one's pretty simple. It's just H, H, and H, right? All has no tail. So let's count what are the numbers we have here. So in the case 1, we have 1, 2 sub cases. For case 2, we have number 3, right? We have 3 cases in total. So now it still comes to the last step, that is the number of events we are interested in over the total possible outcomes. So, okay, let me zoom out a little bit. Cool. So what are the total possible outcomes? Total number of possible results or outcomes is 2 times 2 times 2 equals 8. Why? Because each time you toss a coin, you have 2 possible outcomes, a head or tail. And each of them are independent event, which means the first time the result you get will not influence the result you get for the next toss, right? So that's always 2 possibilities, 2 possible events. So 2 times 2 times 2 correspond to the 3 times we toss the coin. So that's an 8. Okay, let me zoom out a little bit. So it's asking for what is the desired probability. So in this case, we just have desired probability to be what? There are 3 possible cases that we're interested in over the total of 8 possible situations. So that's a 3 over 8, right? So among A, B, C, D, E, which one's correct? That's option C, okay? So that's for this question. Again, it's a combination of using the enumeration method and also finding the case-by-case solution. So that's for this part. And here again, this is a quick information session. It talks about what are the possible classes you can take as you are preparing for the upcoming 2025 AMC exams. So again, there are HR class, AR class, and there's the upcoming AMC mock test. So if you're interested in any of these classes or activities, you are more than welcome to add me on my WeChat. So my working WeChat ID is thinkvip60, T capitalized, V capitalized, no space in between. Another thing that I do want to mention is that there is a Facebook group for the AMC preparation. So you can search on the searching title AMC8 helpful and educational math resources. So when you join the group as a member, you are not only having the access to a lot of valuable practice problems you can use to study for the exam. Also, there will be some valuable exchange of information, right? So you can know what are the other people's experience to get ready for the exam. What are some common mistakes you will try to avoid yourself? So please join it. All right, so now we are going to the exit ticket. So last 3 of the problem. So Angie, okay, so these are names. So how about let's just give them a number, which will be more convenient, right? So I'll say Angie is 1, Bridget is 2, Carlos give a number to be 3, and Diego is 4. Okay, so they are seated at a random around a square table. So let's try to draw a more concrete illustration. So I'll say there's a 1, there's a 2, 3, and 4. Of course, there are more than one possibility. They can sit in a alternative order, but I'm just writing that as an example, okay, for visual purpose. So one person to a side, what is the probability that Angie, which is our number 1, and Carlos, which is our number 3, they are seated opposite to each other? So in this case, Let's try to start with a fixed person. So let me zoom out a little bit, and I will zoom in. I don't know why. So I will say our step number 1 is that suppose 1 is assigned. Our number 1 is Angie, right? Suppose 1 is assigned. Another way to say that. Now let's put a fixate for Angie. She cannot move any longer. So there should be 3 vacancy, right? So in total there are 4 seats. Since one of them is already occupied by one of the guests, only 3 are left. So there are 3 vacancies. 3 vacancies. Good. So how many people are waiting to be seated? Also 3, right? And 3 people. So in this case, we are really having a case of finding 3 people to fill in 3 positions, right? So that should remind you the idea of factorial. So I will say I have 1, 2, 3 positions. So for the first person, he or she has 3 options. She can choose whatever of those among those 3 seats, right? However, for the second person, since another seat is already occupied, only 2 more seats left. So he or she only have 2 options to choose from. And for the last person, really he or she does not have any choices, right? Just see whatever is left. Okay, so that's for the first step. So this is actually 3 factorial, which equals to 6. Okay, 3 times 2 times 1. So that's for our first step. So I will say this is the total of possible arrangement. Possible arrangement. Okay, cool. So now let's move on to our second step, which is since now Angie, which is our number 1, is already seated. How about taking the opposite of Angie? So there should be what? Okay, so let me first write down the given condition. Since number 3, which Carlos is supposed to be sitting on the opposite side of Angie, which is number 1. So since 3 is opposite to 1, right? So that's what given to us. Then after 1 is assigned, 3 seat is also fixed, right? So number 3 seat is also determined, is also fixed. Why? Because think about that. Since 3 must be sitting at the opposite of 1, so when 1 sitting down, there's only one opposite seat to that direction, right? So after 1 is fixed, we also can, which also indicates where is 3 sitting at. So we'll say after 1 is assigned, 3 seat is also fixed. So which means among the 4 original seats, 2 of them is already occupied, being taken. So only 2 more vacancies are left for the 2 rest people, right? So I will say there are 2 vacancies for the last 2 people. For 2 people. In this case, we are having another factorial calculation, which is 2 times 1, right? Because the first person have actually 2 choices to choose among the 2 seats, while after he or she being sitting down, there's only 1 more seat left. So the last person can only take that seat, whatever is left. So this 2 times 1 equals to factorial 2, which equals to 2. Okay, now think about how this contributes to our final conclusion. I'll say that's our step number 3. So therefore, the possibility, oh, sorry, I'll just write probability, okay? It reads better. So the probability, let me clean this part real quick. All right, so probability. So the probability of 1 is opposite to 3. Is what? It should be 2 over 6, right? From our result finding in the number 1, number 2 steps. Why is 2? Because 2 means after number 1, number 3 is already seated. There are 2 options for the rest people, and each of them option is considered valid for this question, right? And what does 6 mean? Again, as I marked, 6 is the total possible arrangement because after number 1 sitting down, there are 3 more seats left for 3 people. So that's how you get 3 factorial, which is 6. Okay, so we can definitely do a simplification on 2 over 6, which now gives you 1/3, 1 over 3. Okay, again, from A, B, C, D, and E, let me zoom out a little bit. So what is the correct answer? It should be B, right? 1/3, 1 over 3. All right, so here should be one more or two more problem. So the faces of each of 2 fair dice are numbered from 1 to 3, 5, 7, and 8, right? So 1, okay, let me first highlight that. So first of all is 2 fair dice, and there are 6 numbers, each marked on a side of the die. So 1 and 2 dice are tossed. What is the probability that, okay, I zoom in too much for no reason. So their sum will be an even number. So this really tests you something about the number theory, right? So this is a quick fact. We all know that if we're adding two odd number, it's guaranteed that their summation is going to be even, right? You can, if you don't believe me, you can try it yourself. Think about you do 5 plus 7, you get 12, right? Another example can be 9 plus 3, you get 12 as well. So every time you are plussing two odd numbers, you're guaranteed to get an even number. That's true, okay? So another possibility is you have even plus even. That's definitely an even number, no explanation needed, right? So that's the two cases which are satisfying the restriction provided here. And there should be some cases that are invalid in this case. So this gives you an odd plus even. And of course, you can change its order to become even plus odd. So even plus odd plus even, you are going to have odd numbers. So for example, 4 plus 3, you get 7. 8 plus 7, you get 15, right? You can never get odd, never get an even number by doing this kind of addition. So after understanding this, we are really halfway through solving this problem. So for the second step, we can say that among the given sequence of numbers 1, 2, 3, 4, 5, 7, and 8. Okay, so these are 6 numbers provided. Okay, what are the even numbers? Let's list them. Okay, all right, let me zoom out a little bit. Okay, so for the even numbers, we only have 2, right? 8 and 2. So what are the odd numbers? All the rest. 1, 3, 5, 7. So it's a 4 to 2 relationship. Okay, so after this one, we just jumped to our last step of solving the problem. So consider about the two cases that we are looking for, where both odd numbers adding up or both even numbers. So for the both odds, the first die can generate 4 possible numbers for the odds, 1, 3, 5, 7, and so does the second die. So this means among each of the 4 numbers on the first die, that is odds, they all each of them corresponded to 4 other numbers that are on the second die, which is odd, right? So this one gives you a 4 times 4 for the possibility, which is 16 possible cases. Now, same idea. Let's think about how about the number appear on the side of both sides, they're even. So for both evens, since only 2 out of 6 numbers that are even, so it's a 2 times 2, right? So all right, let me zoom in a little bit. So 2 times 2 is equal to 4. Okay, so 16 plus 4, 20. We are only considered interested in those 20 cases. All the rest, they are not even, right? We're only looking for the even outcome. So we are good for the events of interest. Now let's find the total. Each of the die has 6 sides, and each of these sides can be shown up. And so does the second die. There are 2 dice, so 6 times 6. You get a total of 36 possible outcomes, right? So that's a 6 times 6, which equals to 36 cases. And the final step should be fairly straightforward. Let me zoom out a little bit. So I will say there are what? 16 plus 4 for the numerator and 36 on the denominator, which gives you a 20 over 36. And of course, they can be simplified, right? They share the common factor of 4. So if you divide 4 on the numerator, you get a 5. So same deal on the denominator, you get a 9. So there are 5 over 9. So the probability is. Okay, so let me rearrange my words. Okay. All right, let me get my eraser. So the desired probability should be 5/9, or you can say fraction. The probability is equal to 5/9, right? Again, how do we get 5/9? 5 is actually, before we simplify, it's 20/36. 20s come from when both sides shows an odd on the top, or both sides shows an even number on the top. So they combine to be a 20 cases among the total of 36 cases. Since it's asking for probability, you just do the formula of the eventual interest on top for the numerator and the total possible events on the bottom on the denominator, right? So after simplification, you get 5/9. Alrighty, so there is a brief information session. I know a lot of the audience, you are preparing for the upcoming 2025 AMC8. So we do offer you a variety of classes. For example, the AR class, which are designed for students who are aiming for the achievement role, and also the HR class. And then most importantly, we're having an AMC8 mock test coming up really soon at the end of August. So if you're interested in any of these activities or the mock exams, or you have other related questions to the AMC8, please feel free. You are super welcome to add me on my WeChat. So my WeChat ID for working is ThinkVIP60 with T and V capitalized, no space in between. Another thing I would like to mention is that, so for those of you who are using the Facebook, you can also search on the title AMC8 Helpful and Educational Math Resources. So after you join this group, you are not only to have access to a handful of materials that you can use to study for the exam, also you can have some exchange of information to peers, right? So sometimes it now be very helpful if you study on your own, you're working everything on your own, but when you're working with your peers, you're giving advice and receiving advice from them, it can be more easier to get a better sense of what is a problem that is likely going to be encountered in the exam. All right, so looks like we are heading to our last problem of this session. So it's saying bag A has 3 chips labeled 1, 3, and 5. So let me highlight that first. Bag A has 3 chips labeled 1, 3, and 5. And there's a second bag called bag B has 3 chips labeled 2, 4, and 6. Okay, very cool. So if one chip is drawn from each bag, why they changed me color? Okay, so if one chip is drawn from each bag, notice you cannot directly draw 2 chips from one bag. Must be one from bag A, one from bag B. That's a restriction, right? So how many different, okay, I zoom in too much. Okay, now it's good. So how many different values are possible for the sum of the 2 numbers? So again, since in this kind of problem, we are just having 3 in one bag, 3 in another, so a total of 6. That's not too much. We can definitely do what? Do the method of enumeration. So I will say, since there are only 3 numbers in each bag, only 3 numbers in each bag. Okay, let me rewrite this part better. I need to really save my handwriting, okay? So there are 3 numbers in each bag. In each bag. We can try the approach of enumeration. We can try. Okay, let me rewrite that part. Enumeration. Okay, so let's list all the possible cases, okay? So I will say for bag 1, bag A, it's not bag 1. The chips are numbered with 1, 3, and 5. And now for our second bag, which is bag B, the numbering are come from 2, 4, and 6. So now let's think about if I randomly pick chip number 1 from bag A. What are the possible matching for me when I pick from bag B? 3 options, right? 2, 4, and 6. So we can use some different color lines to mark down these possible cases. After I get an A, you can get a 2 from B, a 4 from B, or 6 from B. Okay, exactly same idea. If by chance, by random, I choose chip number 3 from bag A, what are the options I may choose from bag B? 2, 4, and 6, right? Each of these choices in bag A correspond to 3 more choices in bag B. So let me highlight a different color. So I'll say 2, 4, and 6 are my options after I determine the one I need for bag A. So lastly, if I by chance choose 5 from bag A, I can have 2 from bag B, 4 from bag B, or 6. So in total, it's 3 plus 3 is 9 possible cases, right? However, it's not going to be 9, not going to be option E, because we are looking for the unique values, the distinct different values. Some of these values are give you the same numbers. So let's still trying to be careful and double check what are their summation. So for the first one, it's 1 plus 2, right? So 1 plus 2, 1 plus 4, 1 plus 6. These are all given the fact that we are choosing what? Number 1 chip from bag A. So that should be 2, 4, and 6, which gives you 3, gives you 5, gives you 7. That's already 3 different values, right? So how about our second possibility? So our second possible case is that we are getting a 3 from bag A. So 3, 3, 3. Let's copy it down. And for bag B, it can be a 2. It also can be a 4, and finally a 6 is also possible. So we can get 5, we can get 7, we can get 9. So you see there are already some overlapping 5 and 7 repeated twice, right? So now we're having 3, 5, 7, 9. Only counted the different values. Good. So how about the last possibility? That is for bag A, we get a 5. So for bag B, we get a 2, or we get a 4, or we get a 6. So that will be a 7, will be a 9, will be a 11. Again, 7 and 9, they are appearing more than one time. So we just count as once. What are the unique values? So I will say the unique, okay? Unique means it only counts as once, right? The unique values, they are having 3, 5, 7, 9, and 11. No more repetition. So that's 1, 2, 3, 4, 5. 5 numbers. So it's asking for the different values. So in this case, we for sure know it's option B, right? The answer is 5. Okay, so that's for this problem. Again, I use the method, a combination of enumeration and also case-by-case approach. So that's the end of this live stream. Also, this will mark the official end of all the, I think, 8-week live stream starting from early July. All right, so thank you so much for coming to today's event, also for the past events. I wish I can see you sometime in the future. All right, have a good one. Bye.